Welcome to this Backspace Academy Lab on programming Amazon SQS and SNS using the AWS Node.js SDK. So in this lab we're going to have two parts to it. The first part is going to look at adding the async package to our Node.js development environment. And the reason we're going to do that is that we want to be able to fire off multiple requests to our AWS SQS service and take advantage of JavaScript's asynchronous nature. So we're not going to be waiting for each one of those requests to finish before we fire off the next one. So this is a big advantage of using Node.js or using JavaScript on the browser side. So we'll look at using the async package, which makes life a lot easier as far as keeping track of those requests for us. Next, we're going to look at creating an SQS queue, and we're going to do that not using the console, but using the AWS Node.js SDK. And then we're going to look at creating some messages for that queue and deliver them to that queue. And then we're going to look at sending multiple messages using the batch method of SQS in the AWS Node.js SDK. And then we're going to look at processing and deleting SQS messages. So we're going to retrieve those messages from our SQS queue, and then we're going to process those and then delete them after we've processed them to remove them from the queue. So then in the second part of this, we're going to look at creating an SNS topic. And then we're going to create SNS messages that will go to the SQS queue, and then we'll be able to retrieve those from our SQS queue using our Node.js development environment. So this is quite important if you had, for example, some CloudWatch alarms or something like that that you would want to act on, or you had some other thing that was sending messages to your application, and you didn't want your application to get overloaded, so you wanted those messages to queue up and for you to be able to process, or your application to be able to process them as needed. You can also use this quite effectively with an auto-scaling group. And so what that enables you to do is to auto-scale, so add multiple instances. For example, if you're using Amazon EC2, to create multiple EC2 instances based upon the size of your SQS queue. So as demand increases, you can gradually increase your capacity of EC2 instances. And you can do that based upon your SQS queue. And then as you've finished processing those and the demand is not there, you can start dropping off EC2 instances. Okay, so now jumping into the Atom IDE, just go into Packages, and we go into Remote Edit, browse our hosts, and then we get our development environment, connecting up to that. Okay, so the first thing we want to do is to grab our package.json file. So just grab that one. Okay, so we're going to add another dependency here. So in this, where we've got here dependencies, and we've got Express, we're just going to put a comma in there and then put a dependency for async.js. So there's put in a dependency there for the async package, and then we just do Control S to save that back to our EC2 instance. And once that's saved, now what we'll do is we'll go back into Remote Edit and we'll pull in our index.js file. So again, browse hosts and connect in to our EC2 instance there. Okay, so it's connected in, so let's just pull in our index.js. Okay, so I'm just going to delete everything that's on there now and paste in the code that is in the lab notes. Okay, so let's have a look at that now. So the first thing we're going to do is we're going to require the async npm package. We're also going to require the AWS Node.js software development kit. And again, a very good note here, don't hard code your credentials. Never use your credentials in your code. Just do not do it. There is no requirement to do that. The best way to do that is to create an IAM role for your EC2 instance to access whatever services it does need to access. We're just configuring our region as before as US East. Now we're creating a new object called AWS.SQS. Okay, so a new type of object that we're creating there, similar to our AWS.S3. Now we're going to pass some parameters to our AWS SQS call. And we've got here the queue name is going to be --lab, and that is required. That is the one thing that is required. Then we're going to pass in some attributes for that queue. So we're going to put in receive message wait time in seconds. Now that is going to allow us to do long polling. So it will, instead of wasting resources by going backwards and forwards and polling, it will allow us to wait until something is available and wait up to 20 seconds for a message to be available. So that's quite good. You should really use receive message wait time and long polling when you're using SQS. It does save your resources there. The next thing we've got here is visibility timeout. So when we retrieve a message from the queue, we don't want to automatically delete that from the queue. We want to leave it in the queue. The reason we do that is in case something goes wrong and the code crashes or whatever happens, we want that message to still be there and picked up by another instance, for example. But we don't want it to be picked up while we're processing it. So while we're processing it for a time period up to 60 seconds, our message will not be available to other instances. But after that 60 seconds, if it's not deleted, then it will be available to other instances to access and process and also delete themselves. So once we've set up those parameters, we can pass those parameters to our create queue function, which is part of the SQS SDK. And what we've got here is we're going to console log if there's an error, of course, and we're going to console log successfully created an SQS queue, and then we're going to pass the queue URL from our data object that is returned. So we just Control S to save that back to our EC2 instance. Okay, so once we've passed or uploaded our package.json and index.js files to our EC2 instance, we can use PuTTY to connect into our EC2 instance. So once we've connected in there, we want to cd into our node-js-sample directory. Now, the first thing we want to do is to install our packages that are defined in that package.json file. So we do npm install, which will add in that those npm packages for us, including the async.js package. Okay, so once we've done that, we can do node index.js. Okay, so what it's done there, it's successfully created an SQS queue, and it's outputted there the URL of that SQS queue. So that looks like it's worked perfectly. So what we'll do is we'll jump into the console, the SQS console, and we'll just see if it's actually created that. Okay, so we'll just jump into our SQS console. Okay, and there we can see we have our queue that has been created. And we can see here it's got the receive message wait time of 20 minutes that we defined, and it's got the 60 seconds of default visibility timeout period that we defined as well. So that's working fine. So we can go back to our Atom IDE now and make some more changes. So now that we've created an SQS queue using our Node.js EC2 instance, we can now look at using our EC2 instance also to create some messages to go into that queue. So first thing we're going to do is to do a call to a function, create messages here in our success callback for create queue. So once the queue has been successfully created, we're going to call create messages, which will have the queue URL passed to it. So once we've got that, so we can jump into here, we've got a function that we're going to create called create messages, which will have the queue URL for the SQS queue passed to it. Then we're going to just create a messages array, and we're going to fill it full of dummy messages, but each one of those messages will be different. Now, this is where the asynchronous nature of JavaScript or Node.js comes into play when you're doing this sort of thing. So SQS can receive messages very rapidly, and JavaScript, being asynchronous nature, can fire them off asynchronously. It doesn't have to wait for one of those responses to come back. It will just fire off requests, and it will keep doing that without waiting for the previous one to finish, which is a great thing. But unfortunately, if we did it in here with just a for next loop, for example, we would be firing off 50 of the exact same message. And the reason being is that we're going to fire off 50 requests at the same time, referencing the same parameters. And so by the time we get to the 50th message, those variables have changed, and you will ultimately, all 50 messages will have the same values in those variables sent to them, which will be identical to each other. So the async package helps us with that. So what we're going to do is we're going to do async each, which will go through each item within that array, and it will first of all console log out the content of that message that we're sending. It's telling me we've got a missing semicolon. I'll just whack that in. And then we're going to then look at passing parameters to our send message SQS SDK method. So those parameters, the two required parameters there are the message body, which will have the content of our message, and the URL, the queue URL is required. So that is what is required in the parameters, and we'll pass that to our send message, to the SQS send message method. And then we're just going to console log an error if it occurs, or we're going to console log out the data that is the response data that we get if it's successful. So we just do Control S to upload that back to our EC2 instance, and once that's done, we can go into our PuTTY, into our EC2 instance again, and we can rerun our application. So that's uploaded now, so I'm just going to go back into PuTTY and do node index.js again and see what happens. Okay, that worked. So what we've got here is it's successfully created the queue as before, and then it's successfully sent a message. This is content for message 1, sending message content for message 2. So it's actually sent those messages, and then the responses have come back. So it's come back with a message ID, response metadata, and that's successful. So we've got 50 responses that have come back there, and they're all different. So they've all got a different request ID and response message ID there. So that's working fine. Async.js, the async package, has done its job, and everything's fine. So what we'll do now is we'll look at a different way. Rather than sending each one off individually, each message off individually, we can send them off as a batch. And so we'll just jump back into Atom ID, and we'll sort that out next. So now I've just updated our create messages function so that it takes advantage of batch messaging to the SQS service. So we'll just go through that. So the first thing we need to do is we need to change our messages array, because we can send up to 10 at a time, but we've got 50. So we need to send 5 lots of 10 messages at once, batches of 10. So we've got a multi-dimensional array here, so it's 5 lots of 5 by 10 to make 50. And again, we're going to asynchronously send that, or send those requests to the SQS service. So what the parameters are going to be different this time. So we're going to send the entries, which will be an array of parameters objects for each individual message, and then the same will be the queue URL, which we'll send in the parameters. So what the entries look like is it's going to have the body as before of the message, and it's going to be given a message ID, which we're just going to call it message and then the number of that message. And then we just go through until we've got all 10, a batch of 10 populated in our entries array. And so then we can pass those parameters, which will contain all of those 10 messages, to the send message batch method of SQS SDK. So that's how that works. So we'll just Control S that again to bring that, upload that into our EC2 instance. And once that's done, we can jump back into PuTTY and we can run that. So I'll just clear the screen there to make it a bit easier to read. So again, we do our node index.js to run the application. So let's have a look at that. So it looks like it's all worked fine there. So let's just go back in. So successfully created the SQS queue with that URL. Now it's sending the message. This is the content for message 0. This is the content for message 1. So it's going through and it's sending all of those through there. And then it's getting some responses back. Okay. So we've got 40, 41, 42, 43, 44, 45. So we've got all those messages coming through there. So we're getting from 40 to 49. And then we're getting from message 0 to 9. And then 10 to 19. So you can see they're not actually coming back sequentially. So this is again the asynchronous nature. So we're really taking advantage of JavaScript. So these won't always come back, number 1, batch number 1 returned, then batch number 2. So it's really taking full advantage of those resources. So you'll see that they don't necessarily come through. And the last one that came through is from 30 to 39. So again, it doesn't come through sequentially as such. So that seems to be working fine. So what we'll do now is we'll just jump into the console and we'll just see how those messages look inside the console. Okay, so we can see there from before we had no messages available, no messages in flight. So we'll just click on refresh and it'll be loading the queue details. And here we can see we've got 250 messages available. So I've run this a few times and we've got quite a few messages in there. And that looks pretty good. So if we go into queue actions, we can actually view those messages and delete them if we want. So let's have a look at view delete. Okay, so we can start polling for messages and we can view up to 10 at a time. Okay, so there we go. So we've got message 3, 5, and there they are. So we can actually go through in the console and we can delete these if we want, which we won't do because we'll do it through our code. So that is working perfectly, not a problem. So we'll just get out that and we'll jump back into our Atom IDE and we'll look at processing these messages. So now what we do is we would like to retrieve those messages and create an application that is continuously polling our SQS queue for messages. But we also want it to not continuously poll when there are no messages available. So we want to take advantage of long polling, for example. So we're going to have that wait time of 20 seconds. And if it hasn't received a message, then it'll go back. And we're also going to do a thing where we can back off. So if we're polling and we find that the queue is empty, we might want to back off for a minute before we actually start polling again. So we're trying to reduce our resources because we're continuously polling resources. We're going to be paying for those resources. So it's something we don't want to do. So if we have our SQS set up and we think that, oh, well, the maximum we can wait is around about a minute or so. So it's quite feasible if the queue is empty to back off for a minute and allow some messages to come in and wait for those. So the first thing we want to do is we're going to create a set interval. Every second is going to poll our SQS queue. And that function that it's going to do that with is receive messages. So we've got our set interval here every second, which it goes through and calls receive messages function that we're creating here. So what we're going to do is we're going to call the SQS service. So to do that, we need the queue URL. And we're also going to pass, and that is required, we're also going to pass again the maximum number of messages. So we can call up to 10 at a time. So we're going to have maximum of 10 and the visibility timeout as before and wait time of 20 as before as well. Now I'm going to put in here waiting SQS equals true. So what we want to do is that we've got a wait time of 20 seconds. So if we get in there and we do a call and we've got to wait 20 seconds for a message to arrive or a response to arrive, whereas this is firing off every second, we want to halt this. Okay, so when we're waiting for the SQS service, we don't want to continually start calling the function again. So we're just going to back that off. So we've got that if not waiting, then we continue to go. If we are waiting, we don't continue to go to receive messages anymore. So then we go to our SQS SDK receive message method, and we pass those parameters to it. And if we get an error, we will again do SQS waiting is false. So we're finished with the SQS service, and we're going to console log out that error. But if we don't get an error, then we're going to again say that the SQS polling can continue now, and we're just going to do a bit of a error check on the data, and then we're going to console log that data out, or data messages.length out to the console. If there is no, if we do get a successful response, but there are actually no messages, then we're going to console log out that the queue is empty, and we're going to wait for 60 seconds. And so that's where we do our back off. So if the queue is empty, we don't want to continually poll the queue every second. So we probably want to back off for a minute before we start polling the queue for any messages. So we've got there a queue counter, and that is decremented every second here until we get to 60 seconds. So if it's less than or equal to 0, then we can go through and we can start receiving messages again. So that's pretty self-explanatory. One thing you might ask, though, is that why are we actually polling? Why don't we take advantage of the asynchronous nature of JavaScript and just pull every single message out of the queue? Well, the reason we don't do that, because that would defeat the purpose of having Amazon SQS. So SQS decouples you from that. So if you were just to pull in every single message from SQS at once, then in one hit, then you would not take advantage of SQS at all, and you would probably end up crashing your EC2 instance. So the better way to do that, to manage if you can't keep up, is to have an auto scaling group of EC2 instances. So if the queue gets too big, you would pull in further EC2 instances to cope with that, and that's the way you would manage that. So we'll just Control S that to upload that to our EC2 instance, and we'll go back into PuTTY and we can run our application, and hopefully we're going to clear the queue. So node index.js again to run our application. Okay, so it's gone through and done what it's done before as far as creating a queue, creating the 50 messages and uploading those 50 messages along with the existing messages that were all there. Last time I looked, it was about 250, 300 messages that I'd put in there. So we can see through it's going through and receiving 10 messages at a time. So if we go into our SQS console, we should see the number of messages going down. So let's just have a look at that. So I just refresh. Okay, so messages available, messages in flight. Okay. And we can see there's not much happening. And there we go. So it's coming down there, messages available 5. But we've got a whole heap of messages in flight. Okay, so no messages are available, but we've still got a heap of messages that are in flight. So we'll go back into here. And we're still pulling in these messages. So they're still coming in. So the messages, the queue is still big, and we're still pulling in messages. So just Control C that to stop it. So what's happening is we are reading our messages, but we're not deleting them after we've processed them. So that's what the problem is. So next thing we need to do now is to process these messages and then delete them after we've processed them from the queue. Okay, so what we're going to do now is we're going to pass in the success callback of our receive messages function. We're going to pass a call to a new function called process messages, and we're going to pass the actual messages. So data.messages, so the response that we get from our receive messages method call from the SQS service, we're going to pass those messages to this process messages function. And what that's going to do, so this new function here is going to grab those messages and it's going to process them. Now our form of processing here is just going to be to console log out the body of that message. But in a real application, you'd probably be looking at something like processing an image or processing some file, converting a file or something like that. But for this lab, we're just going to pass out the message to the console. Then we need to delete that message from the queue. Otherwise, it's going to be there forever. We're just going to keep reading it, and then someone else is going to keep reading it and keep going on forever. So we need to call this SQS delete messages method. So what we need to pass to that in our parameters is the queue URL and the receipt handle, which we get from the content of that message. And so that uniquely identifies that message. And so we've got the queue URL and the receipt handle. The SQS delete message method can delete that message. So then we're just going to have a console log if there's an error, or we're going to have a success message there. We're going to just respond out the console log out the response from the delete message method. So we'll just Control S that to upload it to our EC2 instance again, and then we'll just jump into PuTTY and run that again. Okay, node index.js, and let's see what's happening now. Okay, it's done the same thing, and now it's not only reading the messages, it's processing them and deleting them. So we go back into our console and we refresh that. We'll see this number going, so messages available, 370, 320, 300. So we're slowly getting through all the messages now. Not many in flight, it's processing them quite quickly. One in flight. And it'll keep going until all of the messages are processed and deleted. You see a lot of times here we don't have messages in flight. So that means that we could probably have a little bit extra capacity available on an instance. So you might want to reduce that polling time down from 1 second down to 100 milliseconds, for example, if you want to take advantage more of your resources to process stuff quickly. And this is the kind of things that you would fine tune with that interval and the processing time for what you're doing. So just refresh that. And there we go. So we've got no messages available and no messages in flight. So just jump into the thing here. So SQS queue is now empty and it's waiting for 60 seconds. So it'll back off for 60 seconds and it'll just try and check the queue again. So that's all working fine. So we've successfully created a queue using the Node.js software development kit. We've added messages in batch format to that. We've read those messages back out again. We've processed and deleted those messages. So we've got all the basics of a DevOps application that you could use for whatever it be, for processing files or images or whatever it is. So that's it for part 1, and I will see you in part 2, where we'll start looking at integrating this with the AWS SNS service. I'll see you in the next lesson.